Welcome back, friends. In this lecture we are going to now introduce you to the bicycle facilities and how to measure the level of service of bicycles. We have already looked at how to determine the level of service of pedestrian facilities and sidewalks in an urban area. Now we are going to introduce you to the different bicycle facilities and how do you measure the level of service using the HCM 2000 method. So, this is a little bit older method, but we will expose you to this method because of its ease of calculation, so that you understand how to what are the concepts, and once you understand them we might get you expose you to the later methods, HCM 2010 methods as well. So, we are going to tell you how to develop level of service for exclusive bicycle paths, for shared bicycle paths, and also for on street bicycle lanes. These are usually the three different categories of bicycle facilities for which the level of service will be calculations will be shown. So, when we talk about bicycle facilities, these are usually modern facilities, new age facilities that we are talking about. We have been riding bicycles for many years now, but we never had facilities that are dedicated to bicyclists. Bicyclists always used to ride along with the traffic, and so the quality of the pavement and the volume of the vehicles on the right of way used to determine what is the level of service provided to the bicyclists. But now when there are dedicated bicycle paths, there are dedicated bicycle lanes on the right of way, there are newer methods of determining how level of services are calculated. When we talk about exclusive off-street bicycle path, what we usually mean is that they are physically separated paths from vehicular roads, and they are only for bicycle traffic, right. So, you might have seen some such facilities which are there is no other traffic that is allowed other than bicycles. So, they are called exclusive bicycle off-street paths. There could be shared off-street paths where bicycle and pedestrian traffic can share the same route. So, if this is only bicycle by that symbol that is shown there, there could be shared paths as well, where bicyclists and pedestrians can share the same path. Then there are bicycle lanes on the street, right. So, these are examples of bicycle lanes on the street, where you have a sometimes these are depicted by a different pavement color. Here in this case it is green, it may be red or it may be some other color, but it is somehow demarcating the bicycle route from the regular traffic route, right. So, there is some kind of a demarcation saying that bicycles can take that route. So, they are called bicycle lanes on street. And then there are interrupted bicycle flow facilities, which are designated bicycle lanes adjacent to roads operating under fixed delays like traffic signals and stops. So, these are more regular facilities that are along with the bicycle tracks. So, there is no physical separation between these two. They may be along with the regular traffic. So, they may be on the road along with the regular traffic and are interrupted just as other traffic is interrupted, right. So, essentially these are the different categories or types of bicycle facilities. In India also we have these facilities that are coming up. They may be in Noida, they are colored in red. In Daman and Diu they are in green. Ahmedabad has some dedicated bicycle lanes segregated from the main traffic, and so has Pune. So, these are some of the urban areas which are seeing dedicated bicycle facilities, which are helping in the safety, helping in the operations of the general traffic lanes as well. So, now that when there are fewer slower moving vehicles on the regular traffic lanes, the congestion is reducing on those lanes, and by providing such dedicated facilities for bicyclists, they are improving their safety as well. What the HCM's 2000, so HCM again is the highway capacity manual developed in the United States. What its method is dedicated for separate bicycle path. So, it develops a level of service method for separate bicycle paths which are only for bicyclists, right. There cannot be any other types of users on that facility, not even pedestrians. So, they are off street shared use paths. Okay, they could be shared use as well, they could be for pedestrians, but they could be only for bicycles as well. So, BLOS does not depend on the path's width, but on the lane. So, what it has been found out, or what the method says, is that it does not depend on the width of this, but it actually depends on whether it is demarcated into two lanes or not. So, that is one of the important criteria in understanding or in developing the bicycle level of service for shared use paths or for dedicated bicycle lanes. 3-lane bicycle paths, better operation than 2-lane bicycle paths, because what the third lane or the center lane does is it allows fast moving bicycles to overtake slow moving bicycles, right. There are always, just like in the regular traffic lanes, you have cars or vehicles that want to move faster versus cars and traffic that wants to move slower. So, always the faster moving traffic wants to overtake. So, in case you can provide a third bicycle lane in your dedicated facility, that greatly allows or helps in the maneuvering of the fast moving and slow moving vehicles, and in turn provides better level of service. HCM 2010 says that a minimum of 2.4 meter for a 2-lane and 3 meter for a 3-lane should be used. Again, these are USA standards. So, we can have our own standards in India as well, based on our conditions, bicycling behavior and available space in our urban areas. But the point to remember is you have to set a standard width. The width has to be there, but within that width, the more important thing is you have to have dedicated lanes, or you have to have demarcated lanes. These lanes help in understanding or in dividing the bicycle traffic into upstream and downstream, or one way and the other way. So, you can demarcate bicyclists. So, bicyclists going in the up direction can go in one lane, in the down direction can go in another lane, and if you can provide a third lane which allows the overtaking, that is even better. So, in measuring the bicycle level of service for off shared use paths, what is the first step in this method is to determine the directional flows. The directional flows are nothing but volume per hour divided by the peak hour factor, right. We have already told you what the peak hour factor is. Peak hour flow rate, peak hour flow ratio, which is the ratio of the peak hour flow to 4 times the peak 15-minute volume, right. In 1 hour, within an hour, there may be times when the bicycle flows as peaks, and when there are times when they are off peaks, less peaks. So, if you can then, if you peak hour flow is nothing but the ratio of the peak hour flow to 4 times the peak 15 minutes. So, if you know the peak 15 minutes, and you will know, you multiply it by 4 times, that will give you the entire minute or entire hour, and then you divide it by the peak hour flow. So, that gives you the peak hour factor. You multiply the volume by peak hour factor by the directional split, right, the ratio of the split north south direction. For example, that is why 2 lanes are given. So, if you multiply it by the directional split, if it is 70-30 or 60-40, whichever it is, 0.6, 0.7, that will give you the directional flow. That is the first thing to understand. And then what it tells you to calculate, what the highway capacity manual tells you to calculate is what is the hindrance faced by these bicyclists. They have coined this term. This term is called hindrance, which are also called events per unit time. So, what are these events? It is the number of bicyclists that are passing, or the number of bicycles that are opposing you as a bicyclist, right. So, number of bicycles. So, these two are given by FP and FM. So, what FP says is the number of bicycles moving in the same direction as the bicyclist. So, if you are driving or if you are riding your bicycle, and the number of bicyclists that are riding in your same direction, right, this is called a passing event. So, you may have to pass those bicyclists, right. You may have to either overtake, you may have to pass them. So, that is a type of an event. So, you are confronted by another bicyclist whom you have to pass or overtake. So, that is an event. That is called an event. The other type of event is number of bicycles moving the opposite direction as the bicyclist. Now, suddenly if there is a vehicle bicycle coming in the opposite direction, that is also an event for you. So, you have to be careful to maneuver safely to the bicyclist that is coming in the opposite direction, right. So, these are the two events on which the bicycle level of service depends upon. So, it says that the first event is the passing event is given by 0.188 times Vs, where you already know what is the Vs, you have calculated in the previous calculation, volumes per hour, right. And the second event is called the Fm in the opposite direction is 2 times Vo, which is equal to 0 when the traffic is one way. So, if both lanes are going in one direction, there is no point of calculating the opposing events, because it has no vehicles, right. So, Vo is the flow rate of bicycles in the opposing direction, whereas Vs is the flow rate of bicycles in the subject direction, and you know already how to calculate flow rates. So, if you know the number of passing events and the number of opposing events and the total events, then the total events Fp is the total events F is given by 0.5 times Fm plus Fp, right. If you know the total events, then but more weightage is given to opposing events, because it has been noticed in the field that it is only when there are large number of opposing bicyclists that you encounter that your level of service goes down, right. You will see how level of service is measured eventually, but it has been noticed that when there are lot of opposing traffic or opposing bicyclists in your direction of travel, then you tend to be driving either slower, you feel uncomfortable, you feel unsafe. So, that is the kind. So, that is why that weightage, the weightage to the opposing traffic is even higher, whereas Fp, the number of passing events, has a lower weightage. So, it is 0.5 times Fm plus Fp will give you the total events. Now, these total events per hour are then categorized into different levels, and each of these levels are associated with a letter grade, which gives you eventually the bicycle level of service. So, the measure of effectiveness or the MOE for the bicycle level of service is the total events per hour. Okay. So, if anybody asks you what is the measure of effectiveness of bicycle level of service as per highway capacity manual 2000, you have to remember that it is total events per hour. So, if it is a two-way 2-lane path, right. So, 2 lanes and in both it is a 2-way path, then if you have less than 40 such events, 40 total events per hour, then you are at a level of service A, whereas if you have greater than 195, you are at a poor level of service, and in between all of these are classified. Similarly, for a 2-way 3-lane path, the values of total events per hour are given here, right. So, when used when both bicyclists and pedestrians share the path. Now, if the next method or the next facility to look at is if the path is a shared use path for both bicyclists and pedestrians, then in that case your passing events are given by this formula, your opposing events are given by this formula, and again your total events where your opposing events have a greater weightage are given by this formula, right. So, what this tells you is that for the passing events, now you have something called a VPS as well, right. VPS is nothing but the flow rate of pedestrians in the subject direction. We already have told you how to calculate flow rate of bicycles, and you have to calculate the flow rate of pedestrians in a similar manner. So, the formula is 3 times the flow rate of pedestrians plus 0.188 times the flow rate of bicyclists, which will give you the number of events in the passing direction, and similarly number of events in the opposing direction will be given by 5 times the flow rate of the pedestrians plus 2 times the flow rate of the bicyclists. Simple enough. So, the Highway Capacity Manual 2000 was the first attempt at developing such levels of service for bicycles. So, the calculations were very simple, but this idea, this phenomenon of incorporating the number of events, which is passing events or opposing events, was first introduced in the Highway Capacity Manual. The later on iterations of the Highway Capacity Manual has further improved them. Indo HCM has still not incorporated. We have not yet incorporated the bicycle level of service, but we hope to do so in our next versions as more and more such facilities develop in our country. More and more dedicated bicycle facilities develop in our country. We also hope to develop the bicycle levels of service. Similarly, the table is given here for shared facilities. The third type of facility is the on-street lane, right. So, you can have bicycle lanes on street, but somehow demarcated from the traffic lanes, right. They are designated for bicycles, generally used for one directional flow. So, since they are on the street as well, so you may have one direction here and you may have another direction on the other side of the street, where the street is also where the regular traffic is also flowing in the opposite direction. The picture shows here a bidirectional on-street traffic lane, on-street traffic bicycle lane, but you may have one direction in one side and the other direction in a completely different side, okay, which may vary from 1.2 to 3 meters. But the important thing to remember is, if you have a paved shoulder, that paved shoulder can be easily demarcated as a bicycle lane. Unlike off-street facilities, vehicles do affect the bicycle level of service in this case of facilities. So, there is an impact, although it is segregated from the vehicular traffic, but since they are at the same plane, since they are the same grade, since they are at grade, there is some impact of these moving vehicles on the level of service of bicycles. Quantifying impact of geometric and traffic conditions on the average and standard deviation of bicycle speeds of the facility. So, when you are developing the BLOS for on-street lanes, you have to look at the impact the geometry and the traffic conditions have on the average and standard deviation of the bicycle speeds, right. Friction with vehicular traffic and parked vehicles. So, if there is another parking lane here, right, if there are vehicular parking lane here, so it causes some friction with the bicyclist, right. Maybe this car has parked and now they open the door to get inside. So, opening this door always makes the life of a bicyclist very difficult, because he or she may get hit by that open door. So, that causes a lot of friction, right. So, that friction also lowers the mean speed, and higher standard deviation is seen in the speeds of on-street bicycle lanes. So, here you can see again the number of events is the measures of effectiveness, bicycle flow rate given here, the standard deviations are given here, and the mean speeds are given here. So, by number of events in this case is given by 2 times the bicycle flow rate times the standard deviation divided by the mean bicycle speed times pi. Okay. That is a formula to determine the number of events. So, as the number of events decreases, the standard deviation also decreases, standard deviation of the speed also decreases, and the bicycle level of service uses this table plus the BLOS standards for the off street from the previous slides, right. And a mean bicycle speed of 18 kilometers per hour is considered. So, these are all values of number of events that take place for such kind of flow rate and that standard deviation. Okay. So, we will give you an example and it will be easier for you to follow. So, the first example says In a north-south uninterrupted flow, two-lane exclusive bicycle path carries two-way bicycle traffic, right? Calculate the BLOS for this bicycle path given the following data. Peak hour factor is 0.6, there are 2 lanes, the peak hour flow is 90 bicycles per hour and the directional split is 70-30. So, what do you know about it? It is an uninterrupted flow of 2 lanes, exclusive bicycle path. So, for the exclusive bicycle paths, you know that to calculate FP and FM, these are the formulas. However, first you need to know the directional flows. In order to know the directional flows, you know the peak hour is 90, you are given the volume per hour is 90, you know the peak hour factor and you know the directional split. So, northbound is 70 and southbound is 30. So, you can calculate the volumes on flow rates on northbound and southbound. Using those flow rates, you can calculate the FP for northbound and FP for southbound. So, when you are using the VS, you are using the 105 for northbound and 45 for southbound. Similarly, FM you can calculate for northbound and southbound, and then you can sum it up to measure the total events, which are 65 events per hour in the northbound and 114 events per hour in the southbound. So, the northbound and southbound have two different levels of service, where you see that the southbound is has a poorer level of service because it has higher events per hour that it is facing. So, you can even know it per direction. So, if you have two directional and bidirectional flows, you can even know the level of service in two different directions. The second one is the second example is a 1.8 meter wide on street bicycle lane which carries one way bicycle traffic. Now, if you have to calculate the bicycle BLOS given the following factors, given the following inputs, let us see how you can do it. You know the peak hour factor given is 0.75. There is heavy side friction due to large vehicular volume, right? There is high driveway density. Highway driveways means there are a lot of land uses that have access points to the main road, which will interrupt the bicycle flow as well. Peak hour volume is 150 bicycles per hour. Mean speed of bicycles is 18 kilometers per hour, and the standard deviation is 4.5 kilometers per hour. So, since it's a one way bicycle train, so P will be equal to 1. So, when you calculate the peak hour volume is converted into directional flows by just dividing this by the peak hour factor, and you know that it is 200 bicycles per hour, and given the standard deviation of 4.5 kilometers per hour and speed of 18 kilometers per hour, from the table you can know that the F has to be right. So, bicycle speed is 18, bicycle flow rate you have known as 200. So, you know that is 200 here, and the standard deviation is 4.5. So, within 200 you can have different standard deviations. You pick the 4.5 and you go here. So, this will be the total number of events as 56. So, if you have the total number of events as 56, then you can go back to your standard table and you can know that the level of service of that on street facility is B. Okay. So, that is how you measure the level of service of on street facilities as well as of protected bicycle lanes that can be either exclusive to bicycles or can be shared with pedestrians as well. So, we have shown you 3 different types of facilities and how do you calculate the bicycle level of service for these 3 different facilities using the highway capacity manual 2000 methodology. Here are some references for it. In conclusion, what we have looked at is bicycle level of service depends upon the hindrance faced by the bicyclists, right. So, that is the terminology you have to remember, and the measure of effectiveness of bicycle level of service as per highway capacity manual 2000 is given by the number of events per hour, and number of events are They could be passing events or they could be opposing events. That is the basic thing you have to keep in mind. Thank you.